Question 5. The diagram shows a 6 kilogram particle connected to a 12, and they're on other sides of this triangle, and they're connected by a string. And we're told something about the angle. The angle of slope in both cases, the inverse tan of 4 over 3. So let's just quickly do our tan diagram. Tan of A is opposite over adjacent. So we have the cos of A to be 3 over 5 and the sine of A to be 4 over 5. So we deal with the 6 kg first. We have friction in this case. We do have friction, so we have mu r. So we have r. We have 6g. I'm just going to call my angle A, and I'm going to write in this direction. We're going to have 6g cos A, which is equal to 6g by 3 over 5, which is 18g over 5. And in this direction, we're going to have 6g sine A, which is equal to 24g over 5. And we have tension in the string going this way, and we have acceleration going this way as well. We also have mu r, so I need to get r, so r is equal to my 18g over 5. This force here equal to my r going up in this direction up here. So we are told mu is 6th, so mu r is equal to 18g over 6 times 5, which is 30, and that's going to be 3g over 5. So my equation then is the only thing going in this direction is the t. So we're going to have t minus this here, 24g over 5, 24g over 5, and my mu r, which is 3g over 5, and that's equal to ma, which is equal to 6a. So t minus 27g, minus 27g on top over 5 is equal to 6a. So that's our first equation here. 5 doesn't want to be inside. So if we look at the 12 kilo, so 12 kilo here, string, 12g. We are told the same angle, so A and A. So adjacent to A, so we're going to have 12g cos A, which is equal to, what do we have for cos A? 3/5. So 12g by 3 over 5 is 36g over 5. And in this direction here, I'm just going to bring it a bit further. This direction here we have 12g sine A, which is 12g by 4 over 5, which is 48g over 5. We also have mu in this direction, and this is the tension on the string, so we have mu r going back in this direction. So r is equal to, it's a different r, so I'll call it r1. I don't want to call it the same r. r1 is equal to this 36g over 5. So mu r1 is equal to a sixth of that, 36g over 6 5s, 30, so that's 6g over 5. So that's what's resisting. So acceleration is going in this direction. So force in that direction is this one here that we pulled out. It's going down that way, so our equation is going to be 48g over 5 minus what's opposing it, which is t, and also mu r, which we've got above, which is 6g over 5, and that's equal to m8, or 12a. If we tidy this up, we're going to get minus t, and that's going to be plus 42g over 5 is equal to 12a. So we have another equation. We should be able to solve these because we have a minus t and a plus t. So if I bring these two together, instead of having to write them out again, you can see what's happening here. The t's are going to cancel. 42 minus 27 is 15. So 15g over 5 is equal to 6 and 12, 18a. So a is equal to, well, that's 3g on the left. So we could say it's going to be 3g over 18, or g over 6 meters per second squared. So that's my acceleration. What do we ask for? The tension as well, I'd assume. Tension, acceleration and tension. So give me an equation for t there, an easy enough one for t. Well, let's use this one here because it's here. T is equal to 42g over 5, and that will be minus 12 times a, which is g over 6. So t is equal to 42g over 5 minus 12g over 6, which is 2g. So that's 42g over 5 minus 10g over 5. So t is equal to 32g over 5. And that's in newtons.